Okay, so now we're doing part B. Part B is a little bit trickier. It's not that bad, but it is a bit trickier because I need you to focus with me on this one. So here, you see that the force is not exactly acting like it was in part A, like this. So that means, no, we're not exactly, we have to resolve it into its components. We're not exactly acting only on the x-axis, right? We have a y component and an x component. Now, how do we find them? Okay, we're gonna do some very easy vector addition. So, first of all, let's find this angle here. So, let's keep just projecting this force. Let's find this angle here. Okay, this angle, now I don't know if you noticed, right? This is horizontal. Right, this ground, this is the ground. The ground is obviously going to be horizontal, right? And they told me that this force is applied horizontally. So what does this mean? This and this are parallel. So what do? We have this angle theorem from grade 6. When it makes a Z, what was called alternate angle theorem. So when it forms a Z shape, this angle here and this angle here are going to be equal. So we have 30 degrees now, right? So now very, very easy. We can resolve it like this. First of all, we have our x component. And we have the y component. Now you're telling me, okay, how do I know which direction is the y component? And it could be in two directions. It's absolutely right. It genuinely could be in two directions, and that's very, very fine. That's not like the end of the world if we don't know it. Because why? We can find it. So this is our, let's take this as our hypotenuse, right? This is gonna form here, 90 degrees. This is how you resolve vectors, by the way. Let's re-extend this line, right? And then this will be the x. This will be the x component, right? So this is the y component and this is the x component, okay? Now, here you can definitely see you have 30 degrees. This is how you instantly resolve it. Instantly, this is how you're resolving it, okay? This is forming a right triangle. Ignore this very weird, not exactly to scale figure, but yani, whatever, خلاص, there we go. What do we do here? We have 30 degrees, right? Now, what is opposite to this? This is actually gonna be this is going to be here, this x component is going to be 40 cosine 30. Why? Because this is this is what I was showing you in the other question with the weight. This is how you resolve it, but this is in the case of this force, right? You're going to do vector addition, vector triangle rules. So this is 40 cosine 30. Why? Because by SOHCAHTOA, this is a 90 degree right triangle. So you can use the trigonometric thing. So SOHCAHTOA, cosine is SOHCA, so adjacent over hypotenuse. What's the adjacent? The x component of the force, right? So we're gonna write cosine 30 is equal to SOHCA adjacent over hypotenuse, which is 40. So this means that the x is equal to 40 cosine 30. Very easy, very simple, done. This is how you resolve this component. So that means this is obviously not where our component's acting. This is just showing the direction of the force and its magnitude. This is not where the force is acting. It's not the location. Now, this is the x component. So now we can finally write here 40 cosine 30. Okay, now we can see that the y is going downwards, right, from this triangle. So instantly we can write that obviously we're gonna have the y component of the weight, which is what? W sine 30. Or sorry, W cosine 30. I see, I almost fell for it too. W cosine 30. Okay, this is the weight. This is the weight of the object. So we're gonna actually swap this with mg. Mg, and then we're gonna swap it with 5. I've done so many replacements. Okay, now, we're gonna remove this because it's an extra line I don't want. Okay, for this, you have opposite over the hypotenuse. So sine 30 is equal to y over 40. So y is equal to 40 sine 30. Right? So now I don't need this arrow. And I don't need this arrow because we've resolved it. It's no use to us anymore. So here you can write 40 sine 30. Now, obviously, you know the magnitudes of these. Like, it's common sense. We've established how to do this 50 million times. Fy is f sine theta. But why did I do this triangle? Because we don't have the direction. How was I supposed to know if it goes up or if it goes down? This just helped me to establish that it does go down. Okay, now that we have this, we can have the normal. The normal is obviously not that big, but just, whatever. N. Okay, now this is all established. Very good. Okay, the x component of the force. So the x component of the weight. So we're gonna draw an arrow here. Mg sine 30. Okay. Now here you're gonna have friction, right? Because if they're asking us in the question, I don't know if I told you, the least possible value of mu, which is the coefficient of friction. How do I have a coefficient of friction with a number if I don't have friction? So very obviously we have friction. Okay, now this is our complete diagram. It's very nice, very simple, really. It's a nice question. Okay, so now we just have to resolve. So sigma of x, first of all, why am I not writing? Okay, there we go. What? Sigma fx is equal to, since it says the block does not move, we're in limiting equilibrium. Okay, so sigma of x is equal to 0. Same thing for sigma of y, by the way. The block is not moving upwards or downwards, so it's fine. Now, we can write 40 cosine 30 is equal to f plus mg, or sorry, 5g sine 30 degrees. Okay, so now that we've established this, this is all we can really go with this, right? So now we can use sigma fy is equal to 0. Right? Now, I forgot to mention, I don't know if I mentioned it in part A. This arrow is very important. They will mark down for it if you don't write it. So, we have n is equal to 40 sine 30 plus 5g cosine 30. Okay, now, we can find n very easily. So, 40 sine 30, so let's just write down 40 sine 30 plus 5g is 50. This is equal to 40 sine 30 plus 50 sine 30. 45. It's not 45. Where did I go wrong? How did I get 45? What? Wait, is this... Oh, this is cosine. Where did I get sine? This is cosine. 5g cosine 30. So 40 sine 30 plus 50 cosine 30. 20 plus 25 radically. This is equal to SD. This is gonna give me 63.301 newtons. Okay, now technically I can find friction. I can find friction here, right? If I rearrange, so let's call this equation 1, right? So recall that equation 1, okay, is 40 cosine 30 degrees is equal to f plus 5g sine 30 degrees. Now you can rearrange. So you'll get that f is equal to 40 cosine 30 minus 5g sine 30 degrees. Okay, now this can be written as 50 sine 30 degrees. So 40 cosine 30 degrees minus 50 sine 30 equals to 40 cosine 30 minus 50 sine 30. 9.64. Let's just write 9.641 newtons. Okay, now, what can we say? F equals mu m. Right? Now, we have n, we have f. So, we can rearrange this to give me mu is equal to f over n. Right? Which equals to 9.64 over 63, 9.641, 63.301. Which equals to answer over 63.301, 0.152. Okay, so this is obviously the least possible value. So we can say therefore mu is greater than or equal to, since they want the least possible value, 0.152. And this is my final answer. Now, Let me compare with the marking scheme. So, again, there's 50 million ways to solve these questions. So, like, if it's not there, it's fine. Don't worry. Okay, where are we? No, I'm here. Okay. So, yeah. You can write this. This is fine. But what they want you to do is friction is less than or equal to mu r. Why would they do that? That's fine. Okay. So the marks you'll get here are r is equal to 5g cosine 30 plus 40 sine 30. So r in our case is n again. N is equal to 40 sine 30 plus 5g cosine 30. You get how much is this? M1. And if you attempt to resolve perpendicular or parallel, so sigma of x or sigma of y, you'll get M1. Or sorry, this is A1. Okay. Now, please read the marking scheme notes to understand what these means. This is M is method, A is answer. So, friction, in their case they call it capital F. It is 40 cosine 30 minus 5g sine 30, which is correct. You get A1. And then B1 is just for saying mu is greater than or equal to this, so B1. Okay, so how much do you get? 1, 2, 3, 4. 4. Done. Okay, so the total mark in this question is 8 out of 8. Alright, perfect. So, question 5, or the third question, basically. A particle of mass 0.6 kilogram is inclined on a rough plane where friction, to the horizontal. The particle is kept in equilibrium, very important. That means sigma of x, sigma of y is 0. By a horizontal force of magnitude p newtons acting in a vertical plane containing the line of greatest slope, see diagram. The coefficient of friction between the particle and the plane is 0.4. So mu equal to 0.4. Okay. Find the least possible value of p. Okay, so now this is a very good principle. This is something you need to know, and it is confusing, kind of, if you don't know what to do. So, listen, since they want you to find the least possible value of p, okay? Least possible value of p means that the magnitude of p of x, okay, is gonna be less than the magnitude of the weight on the x component. What does this mean? This means that the object by itself, right? Like if there was no friction, this is how you find the direction of friction. This is what I was telling you. This means that the object by itself, okay, if there was no friction and force P was applied, like this is a smooth surface, it would fall down if we want to find the least possible value of P. This, if we apply P at the least possible value, right? Let's say it was 2 newtons, okay? The weight is going to be greater than this. Again, it's just an example. The weight is going to be greater than this P of X, okay? So it's going to fall down, right? Because then this will be the driving force. This is the net force. This is the direction of the net force. So what does friction do? Friction opposes the direction of the net force. So friction is actually this way, right? So friction is here. Okay, now that we know this, okay, this is the component, this is the P component. So again, let's resolve it. So this makes 90 degrees. Okay, we're just resolving. Okay, this is annoying. I don't like this. So we're gonna resolve the same way we did last time. In this case, this is a bit shorter, so we're just gonna do it like this. Okay, now, wasn't this our hypotenuse? This was our hypotenuse, right? P was the hypotenuse for vector addition. Yeah, it was. Wasn't it? Wait. Yeah, it was. Okay, wait, this is the wrong angle then. This is the right angle here. And then we make this triangle. Whatever, خلاص, we'll just consider it like this. Okay, so no, but this is the net. Wait, one. Okay, yeah, wait, I just realized. 1 second. Okay, yeah, I was right, but I just drew it in a very wrong place. So this is how it's gonna be drawn. 90 degrees. Okay, this is how you're gonna resolve it. So this is py, right? This is the y component, and this is the x component. Again, this always has to be the hypotenuse, okay? So this angle here is 35 degrees, okay? So here x is gonna be what? X is gonna be really quickly p cos 35, okay? So now that you know this, okay, and this one here is gonna be downwards, this y is gonna be p sine 35, right? By the trigonometric ratios, okay? So we don't need this anymore. We know which way the force is going. So p cos 35. And then here you're gonna have p sine 35. Again, these are all not to scale. I don't know if the weight's greater than this. So the y component of the weight's greater than this. I actually have no idea. So that you're gonna write w here, or sorry, mg cosine 35. This is 0.6. Okay, now you have the x component of the weight. Since it's in limiting equilibrium, these two will be equal. So this arrow here is equal to this arrow here. Okay, imagine them equal. They're obviously not equal at all. So 0.6 g sine, let me write it with more space here, 0.6 g sine 35 degrees. Okay, now sigma of x equals to 0. Because again, the thing is in equilibrium, so it does not move, right? Now, resolving this will give me p cos 35 equals to f, or sorry, plus f equals to 0.6 g sine 35. Okay, now this has been resolved. Okay, this is sigma of x. Now, sigma of y is also equal to 0, right? So n, oh, I forgot to draw the normal, didn't I? Yes, I did. It's okay. The n is also equal to the bottom part, so n is equal to 0.6 g cos 35 plus 40 sine 35, or p sine 35, sorry, p sine 35 degrees. Okay, now friction is what? Friction is mu n. So friction's mu n. We can rewrite this as just 6 cos 35 plus p sine 35. You'll see why. I just did g as 10. It's fine. So it's gonna be what? 0.4. 0.4 into n is what? 6 cos 35 degrees plus p sine 35 degrees. All right, now this is equal to, distribute the 0.4. So where's my calculator? Here. 0.4 times 6 is I think 2.4. Yeah, okay, 2.4 cos 35 plus 0.4 p sine 35 degrees. Okay, again, I just distributed the 0.4. Okay, now I can substitute. So this is equation 1. Okay, this is equation 2, right? So I have f, I have whatever. So now I can write sub 2 into 1. So this means p cos 35 equals to 2.4 cos 35, or sorry, no, this is plus. Actually, since I want to isolate p, I can make this easier on myself. So I'll rearrange this to give me p cos 35 degrees is equal to 0.6 g sine 35 minus f. Okay, now this is now very easy, right? Because I have p on one side and I can divide it. So p cos 35 is equal to 0.6 g sine 35, so just 6 sine 35 degrees, okay, minus all of this. So minus 2.4 cos 35 degrees plus 0.4 p sine 35. Now, since this is all under a bracket, I can distribute the minus sign. So, p cos 35 degrees is equal to 6 sine 35 degrees minus 2.4 cos 35 degrees minus 0.4 p sine 35 degrees. Okay, now this is nice because I can take p to the other side, this to the other side, and I'll isolate p pretty much, right? P just gets isolated. So p cos 35 degrees plus 0.4 p sine 35 degrees is equal to 6 sine 35 degrees minus 2.4 cos 35 degrees. Okay, now I can factor p out. So p into cos 35 degrees plus 0.4 sine 35 degrees is equal to, for the millionth time, 6 sine 35 degrees minus 2.4 cos 35 degrees. Right? I'm just rearranging. This is just algebra. Now, I can divide by both sides. So p is equal to 6 sine 35 degrees minus 2.4 cosine 35 degrees. Open this in brackets. Now you know what I'm going to do. I'm going to divide this. So, cosine 35 degrees in brackets plus 0.4 sine 35 degrees. Okay, this equals to 6 sine 35. Let me actually put it in brackets. 6 sine 35 minus 2.4 cosine 35. That's 38. Okay, over cos 35. Where am I? What? My God, I bugged it. Okay, 6 sine 35 for the millionth time minus 2.4 cosine 35. Close this bracket. خلاص, we're done with this. Okay, go down, cosine 35 plus 0.4 sine 35. Done. Close it. 1.41 newtons. Okay, I actually don't know if this is the right answer or not, so let me just check on the marking scheme. I'm pretty sure it is. My math is right. So, let's check. Yes, P is 1.41. So let's check here what they want. Let's check the marking scheme. Attempt at resolving parallel or perpendicular to the plane. So, attempt at resolving parallel or perpendicular to the plane, sigma of x or sigma of y. So, tick, tick. You'll award the mark for one of them though. So, M1. Okay. And then you get R is equal to P sine 35 plus 0.6 G cos 35. R is N. R is the normal reaction. So here, we're focusing here. 0.6 G cos 35 plus P sine 35. Yes. You get A1. Now, use of F, which is friction, equals 0.4 R. So, yes, F is equal to 0.4 and yes, done. So, this gives me A1. Solve for P. Solve for P is dm1. Or sorry, this is m1. What's the second A1? Because I only have one A1. Oh, it's this first, the friction. This one. So now you resolve this one. P cos 35 plus friction equals 0.6 G sine 35. Yes, this is correct. You get A1 for this one too. Also, I'm pretty sure you just need 2 marks after. Yeah, see, like you get 4 marks within the first 4 lines of working. Now, solve for P. So this is all solving for P. So this big tick is dm1. dm1 means like dependent on the other marks basically. And then if you get an answer which rounds to 1.41, you get A1. So now let's count up these marks. 1, 2, 3, 4, 5, 6. 6 out of 6. Yes. So the total is 6 out of 6. Same exact concept. Okay. Oh, where did that paper come from? It's fine. For this one, it's very, very easy. Like I told you, the questions are a bit hard and they do need a bit of thinking, but they are very, very, very repetitive. Very repetitive. They're the exact same concept 5 times over. The only one I say actually focus on, because if you've done these, you've mastered the whole concept. The only one I say focus on is this one. This one's really annoying. It took me a while to figure it out. And the problem is it's worth 9 marks for the second part. The total questions out of 14, so I really suggest you focus on it. And this one is easy. This one's actually very, very simple. I liked it. It's nice. And then you're done with the paper. So we have 3 questions left. And this one we can solve it very, very easy. So find u, which means we don't have to show anything, which means our life is very, very easy. So here, let's resolve it very quickly into its components. I'm gonna do this mentally. I'm not gonna do this on the paper. So this is what 65 cosine 36 degrees, because that's the angle given that it's acting on. Okay. And then obviously this is starting from here. Okay, and then here, since it's going like that, so it's gonna be up here, 65 sine 36 degrees. And then you have the normal. We have friction because they want us to find the coefficient. So unless we don't have friction, then the coefficient is 0, but we have friction, obviously. Friction is gonna be here. Oh wait, we need to check for this condition. We don't know. I'll check for it now. This here is gonna be what mass is this block? 12 kg. So it's given here. 12 kg. So 12g. This is the angle. So sine 24. Let me space it out. Okay. Now we have the y component of the weight, which is what? 12g cosine 24. Woohoo. Okay. Now, let's check for the case of friction. Friction. Check. Is 65 cosine 36. 65 cosine 36 is this number. 12g 120 sine 24. 48.8. So, let's call this force F, okay, big F. So the magnitude of Fx, okay, is greater than the magnitude of the weight of the x component, the x component of the weight. So friction is downward. It's gonna act opposite to the net direction of the net force. Anyway, you don't even need to resolve it like that, because does it say it's moving upwards? I think it does. Okay, wait, no, they told me this is tension. Why did I say this is F? Oh, it's T, whatever. Whatever. Point is, it's letters, whatever. I can call it tareq if I wanted to. Yeah, they did tell me it's sliding up the plane. So anyway, without even resolving it like a triangle, if you have read the question for the next 2 seconds, unlike me, لأني أنا حمار, you would realize that friction is going downwards. Okay, now this is tension. Okay, خلاص, first we're not going to resolve tension like that. They didn't really want the diagram, why should I? Okay, now, so sigma of x is equal to, the block is in limiting equilibrium. So it's not moving up. The block would move up, but it is not. So it's on the point of sliding the plane. So yeah, it's very close. It's like, I don't know if you took the friction chapter. It's gonna be like here. What was the graph? Whatever it was, I forgot the graph. I'm not gonna overyap. It's in limiting equilibrium and it's about to slide up the plane, which means that this force is greater than the x component of the weight and sigma of x is equal to 0. It's literally all that they say. Done. So 65 cosine 36 degrees is equal to 12g sine 24 degrees plus f. Okay, now f equals to mu n. Okay, now to find n, sigma fy is equal to 0. Right? So n plus 65 sine 36 degrees is equal to 12g cosine 24. Sorry. 12g cosine 24. Okay, now this is very easy, right? I have an idea of what's gonna go on. I can find friction since I have this and just friction as the only let's say, so I can find friction and I can find n. So what am I gonna do? F equals mu n, done. خلاص. So n is equal to 12g cosine 24 degrees minus 65 sine 36 degrees, g equals 2. Here's my calculator. So this is equal to 120. So 120, I'll just rewrite it. 120 cosine 24 degrees minus 65 sine 36 degrees. Okay, now 120 cosine 24 minus 65 sine 36. N is equal to 71.41941. Also, we'll leave it up there. I don't know why I expanded so much. Also, we're not gonna use this. This, I don't rely on it. I don't trust it. Because again, you'll see it later, but there's a question. It might be this one. It is this one. The rounding error, I lost a mark on this question because I got 6.24. The answer was 6.26 because I rounded too much. So I'm not gonna do it. I'm gonna rely on this. This is my thing. خلاص. Okay, now we're gonna write recall 65 cosine 36 degrees is equal to 12g sine 34, so 120 sine 34 plus f. Okay, now f is equal to 65 cosine 36 degrees minus 120 sine 34 degrees. So this equals, very quickly, 65 cosine 36 minus 120 sine, how much? 34. What? Wait, why did I say 34? It's 24. Oh my god. Yeah, I also did this problem again. Okay, it's 24. خلاص. This is 24. Gives you 3.777 newtons. Okay, now F equals mu n. So 65 cosine 36 degrees minus, let's put this in brackets, 120 sine 24 degrees equals to mu times what was n? 120 cosine 24 minus 65 sine 36. Okay, now mu is equal to friction over the normal, which is equal to 65 cosine 36 degrees minus 120 sine 24 degrees over 120 cosine 24 degrees minus 65 sine 36 degrees. Do this on your calculator. Oh my god. 65 cosine 36 minus 120 sine 24 over 120 cosine 24 minus 65 sine 86. 0.0529. So I'm not going to write all of that. So I'm going to write it here. Mu equals 0.0529. Done. And this is the answer. Supposedly. I'm again not sure. After that, after like 2 questions ago, I forgot the answers. So attempt at resolving parallel to the plane. So let's mark. Attempt at resolving parallel to the plane. We resolved sigma of x. Yes, we got this. This is M1. The equation is 65 cosine 36 equals to 12g sine 24 plus f a1. F, if you write f equals to 3.777707, which is technically this, it's not this because I didn't expand it fully, but anyway, basically it's the right answer. خلاص, it's close enough. It doesn't affect the calculation. Attempt at resolving perpendicular to the plane, so sigma of y, m1, 12g cosine 24 equals to r plus, which is in our case n, 65 sine 36 A1. This gives you R to be 71.41. Oh, perfect. I got this one exactly. Yes. So A1. I don't know. The significant figures are really confusing. They tell you leave your answers to 3 significant figures, but they don't do it in the marking scheme. Okay, so we have 1, 2, 3, 4, 5. I don't know what's left. What? 1, 2, 3, 4, 5, 6, 7. What? Why is there 7 marks? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. I'm miscounting. 1, 2, 3, 4, 5. Okay, خلاص. What's DM1? Use F equals mu R. Which is this? Yeah, they literally wanted this. This is the answer. This is how they solved it. So yes, DM1, and then this is A1. So how did I get 7 marks? 1, 2, 3, 4, 5, 6, 7 marks. Attempt at resolving the plane. Yes. Yes. Oh wait, I think I put 2 A1s. Yeah, no, this is not supposed to be here. Oh, 6 out of 6. Okay, this is again the same concept, but interesting take on it. So, it's long, but it's easy. Okay, it's really long, but it's really easy. So I don't worry about it. Is this video like gonna be 2 hours long? That's fine. This might be an hour and a half. Okay. A mass of blah 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 blah. It's all given in the diagram. I don't really care. Find the greatest and least possible value. So least value. Let's start with the least value. Okay. For this one, it's actually annoying, the marking scheme. I don't like it. Let's resolve it into its components. So it's like this, then like this. Okay, so that means that the y component is going upwards and the x component is going like this. That's very long. Why did I do it like that? Okay, now this is t sine 60. This is t cosine 60. Okay, now we also have the normal. Always draw the normal. Now there is friction, I'm assuming. Yes, because they did tell me coefficient of friction. This is mu. Okay, now let's see. Least value, obviously the weight, the x component of the weight is going to be greater than the friction. So case 1, in case 1, the friction will actually be moving like this. Okay, this is my first case. The second case is going to be a bit different. So here we're going to take it backwards, right? We're going to take the weight now. So this here is 2.5 g sine 20, and this here is 2.5 g cosine 20. Okay, now are these all my forces resolved? So n t sine 60, 2.5 g cosine 20, 2.5 g sine 20, friction. Yes, everything is solved. Everything is resolved very nicely. So least value of t, sigma fx is equal to, does it move or is it in equilibrium? Held in equilibrium. Okay, so f sigma of x is equal to 0. Now, t cosine 60 plus f plus f is equal to 2.5 g sine 20. Perfect. Now, we're gonna leave it here. Okay, that's pretty much all I need to do. Now, sigma fy also equals to 0. Now, t sine 60 equals to, or plus n, sorry, t sine 60 plus n equals to 2.5 g cosine 20. Okay, now I don't know n, so what will I do? I can actually do work with this. It's not that bad. So I have friction, right? What is friction? Friction equals to mu n. Right? So this equation can give me n is equal to 2.5 g cosine 20 minus t sine 60. Okay, now this will give me f is equal to mu, which is 0.3 n, which is equal to, it is 0.3, right? Yeah, 0.3 into 2.5 g, or let's just try 25. 25 degree, cos 20 degrees minus t sine 60. Okay, now this is f. So what I can do now is write distribute, right? So 25 times 0.3, 15 over 2, 7.5. 7.5 cosine 20 minus 0.3 t sine 60. Okay, now this is now very easy, right? Because I can just substitute friction up here, up there, so I can write now t cosine 60 plus friction, so plus 7.5 cosine 20 degrees minus 0.3 t sine 60 degrees is equal to 25 sine 20 degrees. Okay, now I'm gonna leave t on one side and take the numbers to the other side. So t cosine 16 minus 0.3 t sine 60 equals to 25 sine 20 degrees minus 7.5 cosine 20 degrees. Okay, now this is nice. So you took everything to one side basically. The only thing you moved is actually this to this side, so it's fine. You didn't take anything to one side. Okay, so you can factor out t cosine 60 minus 0.3 sine 60 equals to 25 sine 20 minus 7.5 cosine 20. Okay, so t is equal to 25, let's open a bracket, 25 sine 20 degrees minus 7.5 cosine 20 degrees over cosine 60 minus 0.3 sine 60. This equals to 25 sine 20 minus 7.5 cosine 20. Did I do a mistake in the numbers? I don't think I did. No, I don't think I did. It's okay. Cosine 60 minus 0.3 sine 60. I don't remember it being 6.25. Oh no, it is. 6.25666 newtons. So t smallest is amounts to 6.26 newtons. And I don't like this, so I'll put this. Okay, so this is the first part. Now I'm gonna use the second page because I have a whole page to do the greatest value of t, and I feel like it'll be a neat thing. So I'm just gonna write for whoever is checking this paper, next page. Okay, so now greatest value of t. Everything stays the same for the greatest value of t except one thing. You know how here we said friction is in the same direction as t cos 60? Now it's different because the greatest value of t means that the x-axis or the x component of t is greater than the weight. So it's going to oppose it. So friction is down here. That's the only change. Everything else in this diagram is the exact same calculation. Same process, same everything. So this should actually take me less. So straight away, sigma fx is equal to 0. Right? So now I can write t cos 60 is equal to f plus, what was it? 2.5 g sin 20. Okay, now I'm gonna stop here. So now I'm gonna write sigma of y equals to 0. So t sine 60 degrees, what was it? Plus the normal is equal to 2.5 g cosine 20. Okay, now n is going to equal to 2.5 g cosine 20 degrees minus t sine 60 degrees, which is the exact same number. No, it's like that should be the exact same calculation. So let me just check. Yeah, n is 2.5 g, so 2.5 g cosine 20 minus t sine 60. That's the exact same. Now f equals to mu n, so f is equal to 0.3 n, which is equals to 0.3 times 5g cosine 20 degrees minus sine 60 degrees, which is equal to, I'm just gonna swap this with 50 خلاص. Okay, now this is equal to 15. I got 15 the first time. Wait, this is not, no, wait, 1 second. Where did I get 5? This is 2.5. This is 25. 25 times 0.3, 7.5. 7.5 cosine. Seriously, where did I get 50 from? There isn't even a single mention of 50. خلاص, it's fine. 20 degrees minus 0.3 t sine 60 degrees. Okay, so I can substitute this back in here now. So t cos 60 is equal to 7.5 cosine 20 degrees plus, minus 0.3 t sine 60 degrees plus 2.5 g sine 20, so 25 sine 20 degrees. Okay. This has been a long and tedious process for absolutely nothing. I'm repeating the same problem twice. It's not very nice. So take everything to one side. T cos 60 degrees plus 0.3 sine 60 degrees. We'll leave everything else the same. So 7.5 cosine 20 degrees plus 25 sine 20 degrees. Okay, now I factor t out. This is 0.3 t. So t is equal to 7.5 cosine 20 degrees plus 25 sine 20 degrees all over cosine 60 degrees plus 0.3 sine 60 degrees. So literally it's the exact same numbers, exact same calculations. All we did was change all the minuses to pluses. So I'm not going to do this all again on my calculator. Wherever I see a minus, I'm putting a plus. So plus here, I got 20.529. So 20.5 newtons. Tension is equal to 20.5 T max, all right? 20.5 newtons. Done. Okay, now let me check the marking scheme. Okay, and good news, it is 6.26 and 20.5. So at least this is not for nothing. Attempt at resolving in any direction. Yes. What's this? M1? M1. T sine 60 plus R equals 25 cos 20. T sine 60 plus N equals 25 cos 20. Okay. What's this? B1? It's B1. Okay. So then T cos 60 equals F plus, oh, okay. They took both cases in the same marking scheme, like in the same thing. It's annoying because they did then later take F, they don't take plus or minus. Like they write this in the marking scheme. You can take it in two separate cases like I did. So you can take it this and this. Anyway, so use of F equals mu R. Yes. How much marks is this worth? Or what is this mark? M1. I skipped a few M's. T cos 60 plus F equals, so F in our case is the friction. T cos 60 plus F, so where is it? I did rewrite them somewhere. Here. T cos 60 plus F equals to 25 sin times 20. Yes, this is, what is this? This is A1. As you can see, they arrange the marking scheme in a very weird way. Like, I'm solving in the proper order it's meant to be solved in, but they just don't take it like that. So this is then A1. I think I've squeezed out all the marks I can squeeze out on this question. يعني خلاص. Okay, so this is correct. It's a part of the mark. And then this is the other part of the mark. So I get a M1. Yeah, I got M1. Okay. Now, for writing this, I believe I got another mark. T equals 60 plus F equals F plus 25 times 20. Yes, this is A1. Surely this is 8 marks. I got the answers correct. فخلاص. Oh, this is A1. How much is this? 1, 2, 3, 4, 5, 6, 7, 8. Yes, okay, 8 out of 8. خلاص. Okay. As shown in the diagram, a particle A of mass, blah 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 blah. Oh, I hate this question. It's not nice at all. I hate it with a passion. It's the most annoying question. And if you understand this, you've understood the entire mechanics periodic. Literally, like it's fine, but like I'm not in the mood. It's fine. Sigma Fx equals MA. Oh wait, I forgot to, like, before I'm just so used to writing it. So here, since this is just a horizontal line, you can read it yourself. But I know what they say already. So now here you have the weight, which is what, mg. You don't have any other components. Why? Because it's not on an inclined plane. This one tells me a different story, but this is fine. So here I have tension. Here I have my normal reaction. Is there friction? Surely there is. Wait. Shown the diagram particle mass 30 degrees. Given that both planes are smooth. I need to read the questions more. Given that both planes are smooth. خلاص. Okay. So this is fine. Okay. I don't have any friction on A. Now, for B, we have tension here. This is tension. The normal. The y component of the weight, which is mg, or so much, 2.4g cosine 30 degrees, and then here this is the x component, 2.4g sine 30 degrees. Okay, these are all our forces. This is what is happening right now, and it's not nice. I'm not a fan of this question. So we're gonna use simultaneous equation. Sigma of x of A equals to ma, because they said it's moving. They did say it's moving, and plus they want us to find acceleration. I think you can tell that it's moving. Ma. Okay. Obviously ma, the mass of A times acceleration. Acceleration is both in the same cases, both cases. So this is now very, very easy. Tension is the only force that's acting on the x component, on the x-axis, is equal to m, which is what, 1.6 here, right? 1.6a. I'm not gonna draw the arrow for this house. Done. This is it for A. Now, you can write sigma fy, but it's quite literally useless, because it'll just tell me that n is equal to mg, for this part at least. Now, sigma of f of xb is equal to mb of a, m of b times a. Okay, now we have a bunch more forces acting here. So we have tension minus, or we can just write tension is equal to tension minus 2.4g sine 30 Or wait, 1 second. No. Don't do that. Don't do that. Because acceleration is going this way, right? We took it to go like this, right? We're taking our sense of motion as this, right? So that means it's also gonna go like this. So this is our positive direction. So we're actually gonna write 2.4g sine 30 degrees minus tension is equal to ma, which is 2.4a. Okay, now I can rearrange the equations. So this is equation 1. Okay, now tension for equation 2 is going to be 2.4g sine 30 minus 2.4a. This is equation 2. But for purposes of just simplification, I'm going to write 24 sine 30 degrees minus 2.4a. Okay, now I can substitute this. So sub 1 to 2. So 2.4a, or wait, sorry, 1.6a is to 24 sine 30 degrees minus 2.4a. Alright, take everything to the other side. 1.6 plus 2.4 gives me 4. 4 equals to 24 sine 30 degrees is equal to 12. 4a, this is 4a. Okay, now divide by 4, a is equal to 12 over 4, equals to 3 meters per second squared. And this is the answer. This is the easy part of the question. They still find the tension here, which is even easier because it's substituting. Now, that's acceleration. Recall, we're going to use the equation of A just to be safer. Tension is equal to 1.6A. So tension is 1.6 times 3, which is 4.8 newtons. Done. Okay. So let's mark this. It's 5 marks, so it's not that hard. Like, it's fine. So, attempt Newton's second law for A or for B or for the system. So we attempted it for A and for B. So we got this mark M1. So here and here. We're gonna write this together as M1. Okay, now, two correct equations. We get the mark for two correct equations from this and this. So this is A1. Solve for A or for T, we solved for A. So M1 here. The answer is A1 here. And then tension's 4.8, A1. See that they're distributing marks very freely here. 1, 2, 3, 4, 5. Yes, 5. Okay. Now, it is given instead that the horizontal plane is rough and the coefficient of friction between A and B and the horizontal plane is 0.2. Okay, so mu of A is equal to 0.2. The inclined plane is smooth. So B has nothing. B has no friction. Find the total distance traveled by A. Now, we're going to change this nice, cute diagram. This we're going to keep it the exact same because they told me it's smooth. We're going to write here, there's a nice friction. Okay, now, to find friction, we're going to say F is equal to mu n. Right? Now, F is equal to 0.2 n. Now, how do we find n? To find n, sigma Fy on A is equal to 0. Right? So, it's just n equals mg, literally. N equals mg, which equals to, what was it? 2.4 times 10. Or was it 1.8? What was the mass on you? 1.6. Yeah, 1.6. Okay, I don't know where it is. 1.6 times 10, 16 newtons. Okay, so that means that friction is 0.2 times 16, which equals to 0.2 times 16 is 3.2. Okay, now let's not put a box out of this because the answer is fine. Find the total distance traveled by A. Okay, now this is very, very confusing. I need you to focus with me. Okay, now, here, how do we find the distance traveled by A? The acceleration has obviously changed, right? The acceleration is no longer 3, because now we have friction. and then the pulley is acceleration on the same thing. So we're gonna do the exact same process, but we're gonna consider friction now. So sigma Fx of A is equal to MA, right? So what is now of an Fx of A? Tension minus the friction. So T minus 3.2 T, or let's just leave it, T minus F is equal to A, or how much was M? 1.6 A. Okay, so T minus, or let's leave it on the same line, T minus 3.2 equals to 1.6 A. Okay, which leads me to the final equation, which is 1.6 A plus 3.2. This is equation 1. Okay, now sigma F of X of B is the exact same, should be the exact same thing, yani. So for this one, tension minus 2.4 G sine 30. Or sorry, 2.4 G sine 30 minus tension. So 2.4 G sine 30, so 24 sine 30 minus the tension is equal to 2.4. What was this? Is, yeah, this is 2.48. Okay, so tension is equal to 24. Or let's leave it on the same line because I need to show a lot of working here. Tension is equal to 24 sine 30 minus 2.48. Okay, done. Now this is equation 2. So we're gonna sub 2 into 1. So sub 2 into 1 or 1 to 2, it's fine. Let's save it as 1 to 2. 1.6a plus 3.2 equals to 24 sine 30 minus 2.4a. So 4a is equal to 24 sine 30 minus 3.2 is equals to 24 sine 30 is 12. 12 minus 3.2, 8.8. It's minus 8.8. A is equal to 8.8 over 4 is equal to 2.2 meters per second squared. So this is my acceleration. Okay, now why am I finding this? Okay, it's actually like it's easy once you understand it. That's the thing. Now here distance traveled by B is 1 meters. Okay, but so let's say this here is 1 meter. So at this point here, we'll leave it at the point of tension. So this is 1 meter. So from here to here, it's 1 meter, right? But do you think when the thing stops here, when the ball, when B stops here, it's gonna just stop moving? A is just gonna stop moving? No, it won't. The string will become no longer taut. Taut means like this. Okay, it's a straight line, like it's stretched out. But you know when you have a string that's like, you know, it's loose. This is like what I mean, right? This is called slack, and this is taut. Or taut, whatever you want to call it. Okay, now taut means like it's basically pulled to its maximum, right? It's very, very strongly pulled. But slack means it's not pulled, it's free to move, it's loose, and like this. Okay, so now that we know this, it will move once it's slackened also, right? So here it moved 1 meter. This is while it was taut, right? So that's called A prime. But then it moved to some point, let's say X meters here. So A prime prime. So we're gonna call this X meters. Okay, so this is the period when it was taut, and this is when it's slack. Okay, now let's find the distance, let's find the velocity, right? The velocity will be the same in both cases. So we can take how much the velocity of B is after it traveled 1 meter and equate it to this, because it's the same thing. So we have 1 meter, we have delta x, and it's at UA/RM, because acceleration, constant acceleration means UA/RM. So we have delta x, right? We have acceleration, right? What do we also have? They said from here, did they say it was released from rest? It's released from rest. So initial velocity is given. Okay, we need to find velocity final at A prime, right? So what are we gonna use? V squared minus U squared equals 2A delta x. So V squared is what we want to find. U squared is 0, right? Because they said from rest, equals to 2 into 2.2 into delta x, which is 1. So this gives me V squared as 4.4. Okay, now this leads to V being radical 4.4 meters per second, right? This is V. This is V at A prime. So what are we gonna write here? We're gonna write at this point V is equal to radical 4.4. Okay, now we have the interval between A prime and A prime prime, right? It traveled x meters. We don't know what this x is. So what do we do for this one? Similar concept. Okay, now obviously here this is where it becomes rested, right? خلاص, it stops moving at this point, A prime prime. This is after the string slackened with transferred all its energy, whatever. Oh, speaking of, that's actually a really nice way to solve it. You can use work energy theorem, if you remember it from last year. Here خلاص, no, there's no more things in it, there's no more tension. This is very crucial, there's no more tension. Okay, and it stopped moving here. Okay, so since there's no more tension, we can still write sum of fx. That's the most statistic summation I've ever written. Sum of fx is equal to ma. Right? Now, since when that string becomes slackened, right, the string becomes slackened, there's no longer any tension. Okay, so there's only the friction force. So it's negative 3.2 equals to ma. M is 2.4, 1.6. Leading to this is in phase 2 for let's say the interval of A prime to A prime prime. Okay. A is equal to here, divided, you'll get negative 2 for phase 2. Okay, so it's constantly decelerating at this. Now, obviously it stops moving at A prime prime, right? So initial final velocity is going to be 0 squared minus radical 4.4 squared, because that was the initial velocity in phase 2, equals to 2 into negative 2, because that's acceleration we found, into delta x, which is what we want to find. So negative 4.4 is equal to negative 4 delta x. Delta x is equal to negative 4.4 over negative 4, which gives you on the calculator 4.4 over 4, negative 1.1 meters. What? Oh, negative, wait, 1.1 meters. I forgot to add the sign. 1.1 meters. Done. Okay? Now, this is the distance traveled in phase 2, which is here 1.1 meters. So, now, the total distance is equal to 1.1 plus 1, right? Which is 2.1 meters. Okay? That's the end of this question. Done. So, because they want us to find the distance traveled by A. It's very tricky, but once you get it, it's actually very, very easy, right? So, essentially what was happening? Here, the string was accelerating while it was taut, right? And while it was, this travels 1 meter, right? So the B is going down. B is going down the slope till 1 meter. Now, while this is happening, this is also going down like this. Not going down, but it's moving in the same direction, right? And this time there's an acceleration, because obviously you started from rest and then you move to this point, right? How would you move without the acceleration? In this 1 meter, you had an acceleration of 2 meters per second squared, and then you find the final velocity. The final velocity at this point was 4.4, radical 4.4 meters per second. Okay, now, here from A prime to A prime prime, you don't know how much you move. This is the last thing, خلاص, because then the string has become slackened, it's loose, so you can move, but very slightly. So, you find the acceleration, which in our case was negative 2, obviously because it's going to slow down, right? It's not going to keep on accelerating, or else it'll never stop. So it's going to slow down because we're approaching at this final stop here. Think of it as a train, right? So at this final stop, this is the final stop, so the train's going to stop here, 0.8 meters per second. But it was initially going at a speed of 4.4 meters per second under a radical, right? So we find the acceleration. Okay, once you find the acceleration by doing F equals ma, because at this final point, again, you don't have any other tension. In this interval, actually, you don't have any tension, because you only have tension, okay? You only have tension when the string is taut, okay? When the string is slackened, you don't have tension. So, when you do sum of F equals ma, the only force you'll have is the negative 3.2 from the friction, because that will always stay there, right? It's between the ground. So, essentially, you use negative 3.2 equals 1.6a for some ma. A will give you -2. And then you do v squared minus u squared again, and you'll find the acceleration. And then you'll find the distance, sorry. خلاص, done. So, let's mark. Okay. For this one, let's mark it here. So, red pen. Friction force on A is 3.2 newtons. Yes, that is B1. Okay, now T minus F equals 1.6A. So where is it? T minus F equals 1.6A. 2.4 G sine 30 minus T equals 2.4A. Yes, here. So this gives me M1. Okay, now if you solve with the equations or whatever, you'll get a mark. A is 2.2. This is A1. Subsequent acceleration of A is -2. So yes, A1. This is M1. Okay. Now 1.1 meters, and then the total distance is 2.1 meters. This is A1. So you're done with this question. So 14 marks. Okay, now two particles P and Q of masses 0.3 and 0.2 respectively are attached. This is the last question. Yes, it is. So two particles of P and Q of masses 0.3 and 0.2 respectively are attached to the ends of a light and extensible string. The string passes over a fixed smooth pulley which is attached to the edge of a smooth plane. The plane is inclined at an angle theta to the horizontal, where sine theta is 3/5. Okay, this is very important because this angle, okay, it's a special angle. This, whenever you see it, it is 36.9 degrees. Okay, and this is a Pythagorean triple. So straight away I can tell you with just by reading the question, this is 5 meters here. This here is 3 meters. And this here is 4 meters. Okay, now, just so you know, like, okay, P lies on the string between blah, 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 P is released, and Q moves vertically downwards. So Q literally, we only have two masses on it. We have the tension and the weight. So this is 0.2 G. And this is the tension here. Now, obviously, if it's moving downwards, the tension is less than the weight. So here we're gonna draw it like this. Okay, now, this is for Q. Okay, and P, it's on an inclined plane, so tension here. Okay, you have the Y component of the weight, which is, what was it, 0.3 G cosine 36.9. Okay, and then you have here the X component, 0.3 G sine 36.9 degrees. Okay, and then you have the normal, and that's pretty much it. That's all your forces. Now, find the tension in the string and the magnitude of the acceleration of the particles. So, sigma Fx of P is equal to ma. Okay, now, so Fx of P, yes. So tension minus 0.3 G sine 36.9 is equal to 0.3A. Okay, now, that's pretty much all we can do with this equation. Okay, so actually we can just rearrange it. T is equal to 0.3A plus 0.3 G sine 36.9 degrees. So T is equal to 0.3A plus 3 into 3/5, because remember, sine of this angle is 3/5, it's given to me. So this equals to 0.3A plus 0.18, or 1.8, sorry. 1.8, and this is my first equation. Okay, now, sigma f of x of q is nothing. We're not resolving this. Why did I do that? Wait, do we have anything? No, we don't. We're not supposed to. Yeah, no, we don't have anything. So, all we're gonna do here is sigma fy of q is equal to ma. Right? So, it's gonna move downwards. So that means mg, which is how much? 0.2 g. So 0.2 g minus tensions equal to 0.2 a. Okay, so that means my tension is gonna equal to 0.2 g minus 0.2 a, which is equal to, I can factor out 0.2 and put g minus a, but I don't want to do that, so I'll just do 2 minus 0.2 a. This is equation 2. Okay, now I'm just gonna substitute 1 into 2, which gives me 0.3a plus 1.8, sorry. 0.3a plus 1.8, yes, equals to 2 minus 0.2a. So this gives me 0.5a equals to 0.2. So a is equal to 0.4 meters per second squared. And this is the acceleration. Now we can substitute the tension for any of them. So tension is equal to 2 minus 0.2a. Right? So tension is equal to 2 minus 0.2 into 0.4, which equals to 2 minus 0.2 into 0.4, 1.92 newtons. Okay, this is the last question, so let's just mark it really quickly. We're done. So finally, so for p, t minus 0.3 g, what? Okay, 0.3 equals to t minus 0.3 g 36.9. Yes, so t minus 0.3 g sine 36.9 equals 0.3a. Wait, I'm getting mad at penalty. So this is a1. Oh, so you have to do it for q2. So 0.2 g minus t equal to 0.2a. Yes. So all of this will give me a1. And then if I resolve then x or y, because if we're using Newton's second law, you'll get m1. Okay. Now m1 for 0.2 minus 0.18. So here, yeah. Wait, what? 0.2 minus 0.18 g. Yeah, okay. So you get it for this. m1. For solving the simultaneous equation, for solving the system, خلاص. Whatever. You'll get a as 0.4, a1, and tension is 1.92 newtons, a1. خلاص, 5 out of 5. And the paper total is 54 out of 54. Done. We're done with the paper. Good luck, guys. I know it's been a long video, I'm sorry, but I couldn't explain it faster. I'll try to go as fast as I can.